So this week we're going to take a look at maps. The map is a more involved and interesting data storage device compared to what we saw with the collection. A collection is always going to be, think of it like a bag, a bunch of stuff inside of there just randomly assorted. A set, equally randomly sorted, but just we know there's only one and only one of each of them in there. And then a list is going to have some sort of order associated with that. But that order is only essentially the order they were added in, unless I've arranged them or shuffled them. They're not automatically sorted or anything as part of a list. So a map is going to give us a lot of functions and options based off of how we store data inside of it. Now, the main purpose of a map is you can think of a vending machine. So back in the day, you'd see vending machines, there's still vending machines like this, where you put in a little code, and based off the code, something rolls out inside of here. So if you look real closely inside of there, it looks like, let's just call it A3 as a Snickers bar. So if I put in the code A3, down rolls a Snickers bar for me. If I put in, let's say it's C, 1, 2, 3, 4, 5, 6, 7, C7, you'll get some Skittles out of it. So the code represents to something that's stored on that shelf, if you will. And that magic code represents that thing. So instead of me having to type in Snickers or type in Skittles, I just do A3, just two buttons, and poof, boom, there it comes out. And then that code is somewhat irrelevant to what's coming out of it. It could be a Snickers bar, it could be vegetables, it could be, I saw a vending machine where a kid was doing handmade pottery to show you, hey, don't mass produce things, you can still buy handmade pottery inside of there. Whatever you want to have could come out of the vending machine based off that code. The code is just a quick reference for whatever's stored inside of there. The code is what really counts at this point. Whatever's stored is really less important to us as far as the data structure goes. It's important towards what you're going to use the data for, but it's just a quick lookup mechanism. So how do I use that in my code? Well, inside of my code, I need occasionally to be able to do a quick lookup of things. Now, this is what databases are for, and if you wanted to get there, then you could keep taking classes, and in your next class you'll learn about databases, but a database is a separate piece of software. Sometimes I want to be able to access data quickly from my Java application. And so, let's say I'm storing a list of people objects more specifically. Like we've built in objects, you have a lot of complicated things going on, first name, last name, their age, how much stuff they bought, what their sales total is, all this sort of stuff. Well, how do I look up a person? I could scroll through each one of the objects saying, hey, are you this person, are you this person, are you this person? Or I can have a unique identifier for that person. Maybe their employee ID, maybe their social security number, maybe just their last name, comma, first name. I can put that into an object itself and look up based off of that smaller set of data. And that becomes the key to go get the full object that's out there. I can even store very complicated objects like lists and even other maps of data if I want to. But the idea is I have something similar, some sorting criteria that allow me to look that up more quickly and then be able to access that data essentially instantly as far as my code is concerned. Don't have to do any looping or anything to get that out. So that means the map's capabilities is focused around how I care to store the data that's inside of there. The data being stored, as I said, whatever you want to store, that's fine. It just throws it in there. But there's a lot of rules we have to understand about the keys based off of the type of map we're going to choose. And we're going to look at each of the main types of maps. There's tree sets and hash sets. There's two branches of those, and we'll look at how those work in a little bit. So the main thing I can do with any map, though, is I can put things into the map using a key-value pair. There's always two parameters involved with putting something in the map. What is the key, and then what is the value that's going to be stored there? There's nothing to say they couldn't be the same thing, but it's typically they're two different things because normally it's a simpler data. I can also then get data out of it by handing you the key and you give me the value. So it's kind of like you go to the valet. I hand you a little piece of paper with my number on it, and my car shows back up. Very simple key to get back my whole important object, the car. I can remove things from the map based off of key and value. I can then say, is this key in the map or is this value in the map? I can get all of the keys. I can get all of the values. I can get a key value pair object that's special to maps. I can even add all the contents of one map into another map with just simple high-level commands. But it's important to understand the general rules of what it is to be a map. So maps store data, and so the keys inside of the map must be unique. Think of it as an address. If I have a house at a location and I want to build another house at a location, then I need to give you the right address. We'll look at this in a second. So the values, again, could be anything. It could be a house there, it could be an RV there, it could be a spaceship there, it could be just a bank account, something very virtual. It doesn't have to be something big and physical. It's just whatever I want to look up based off the key value inside of there. But understanding that, the key has to be unique. When I throw something in the map, it adds it to the map. If I try and throw something else inside there, so I have my little plot of grass, I throw a house on top of it. If at some point I say, okay, for this little plot of grass, let's call it 123 Main Street, I want to put a hotel there, then all of a sudden as I come in and do that, then poof, there's my hotel. It's wiped over my house. That house does not exist anymore as far as the map's concerned. That house, poof, is gone. It's not to say it's in the virtual Java world, it's gone entirely. It doesn't delete the object. It's just as far as the map goes, it's no longer there. So the address now belongs to the hotel. I don't want you to take the analogy too far, that we actually wipe out the object. But in that map, if I apply a second key, I don't have both a house and a hotel there, the house is gone. It now points to the hotel. Same way the other way. If I put the house inside of there, poof, the hotel goes away. So that is the start of it. Let's jump now to the next video to talk about what tree maps are.